Okay, so welcome back. Now let's do another example. And so here we've got another type of series. We want to see if it's telescoping. And if it's telescoping, then we also want to see if it converges or diverges. Okay, so let's look at the partial sums. Okay, so let's look at some of these partial sums. S sub 1. Well, what's S sub 1? It's going to be e to the 1, right? So it's just going to be e, right? Minus e to the 1/2. Okay? Now S sub 2 is going to equal the first two terms, so that's going to be what? E minus e to the 1/2. Then it's going to be what? Plus, now the second one, with n is equal to 2, you get e to the 1/2 minus e to the 1/3. But again, you could drop the parentheses here because you're just adding, right? So you could drop the parentheses. So now, what happens? You can easily see that these terms are going to cancel, and so you get e minus e to the 1/3. Looks familiar. So now S sub 3, you get e minus e to the 1/2 plus e to the 1/2 minus e to the 1/3 plus e to the 1/3 minus e to the 1/4. Okay, and notice that again, the middle terms cancel, and you end up with e minus e to the 1/4. So now again, if we keep going, boom, 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 and we go to S sub k, we see that this is going to end up being e minus e to the 1/k plus 1. Okay, so now again, we look at the sequence of partial sums, right? But remember, the convergence of the sequence of partial sums depends on the sequence of this. So really we have to look at the sequence of e to the 1/k plus 1, right? But really it's this, right? If this converges, if this here converges, then obviously it's going to converge to a number which is going to be e to that number, right? So again, if we look at 1/k plus 1, right, again, we know that this sequence of numbers, right, converges, right? So if we look at the sequence of 1/k plus 1, we know that that goes to 0 as k, as k goes to infinity, right? So this goes to 0 as k goes to infinity, which means that as k goes to infinity, e to this is going e to the 0, right? Which means it's approaching what? 1. E to the 0 is 1. So that means that the sequence of partial sums is approaching what? E. E minus 1. Right? So this going to 0 implies that what? That means that the sequence of e to the 1/k plus 1 is approaching e to the 0, which equals 1, as k goes to infinity, which then tells us that the partial sums converges to e minus 1 as k goes to infinity, which means that the series converges, and it also converges to the same thing. It's going to be equal to e minus 1. And that's the answer. Have a great day.